So as expert group A, your job is to watch this video and work through some of these problems on the chain rule, specifically dealing with functions that are raised to a power. So sometimes you'll see this called the power rule. So we're going to go through a couple examples, and as we go, keep in mind there is a pattern, and that's what you're looking for. You want to be able to take that back to your group and show them the pattern that they're looking for. So let me start off with one example. Let's suppose that the function is x squared plus 1 all raised to the third power. So the problem we have here is we've never had anything quite like this before. What we've had is something like maybe x to the third. And so if you had x to the third, that's an easy derivative. All we have to do there is use what we know as the power rule, which means you bring the coefficient down, and then you reduce the power by 1. The problem is, though, we have never had a situation where the thing that you are raising to the power is more than just an x. And that's kind of where we're looking at, the things we're looking at today. And that's why we need this thing called the chain rule. So it's kind of like a chain reaction or a chain effect of one thing being derived and then something else. So the way I'd like you to think about this is think about it as more of an inside function and an outside function. And the way we look at that is the outside function is something being raised to the third power. So we'll say, in this case, that's x squared plus 1. The inside function is that piece that is being raised to the power. So the outside is really the power itself, and the inside is really the x squared plus 1. So in a case like this, let's make the outside function, let's just call it x cubed, and let's make the inside function x squared plus 1. So the chain rule looks like this, right? We have a function with another function inside of it. So that's how we start. The way we derive that is we take the derivative of the outside, so f prime, leaving the inside alone, and then we multiply that times the derivative of just the inside. So that's a lot. Let's kind of say that again, right? It's derivative of the outside, so derivative of the outside times the derivative of the inside. And so on the next screen, we'll walk through this problem, breaking up these pieces and showing you how this works. So let's say, again, we have x squared plus 1 to the third power, right? So that's our function. So if the outside piece is x cubed, and the inside piece is x squared plus 1, how does that work with that definition we just talked about? Well, let's figure this out here. So we have the derivative of the outside. So when we say y prime, we're going to derive the x cubed piece. So that's 3x squared, except instead of me writing x squared, I have to keep the original inside function in there, right? Then we're going to multiply that times the derivative of x squared plus 1. And that's just 2x. And that would be it. I mean, the most you might want to do from there, maybe if you're looking to simplify a little bit, is you would say, all right, my final answer is 6x, because you can multiply that 3 and that 2x right there, times x squared plus 1 to the second power. So a lot of things happened real quickly there. Let's just talk about that again. We executed the power rule. We brought the 3 down. We reduced the power by 1, right? We never changed the inside until we were done doing that. Then finally we derived the inside. So obviously one example is not going to do it. So we're going to go through a couple more. Remember, as we go through these videos, you can always pause them. You can always play them again. Anything you need to kind of capture what it is you're looking to do. So let's say we have f of x equals 1 over x cubed minus 4x, but all of that, let's say, is raised to the fifth power. Now, given what we know, you might look at that and say, oh, I think I'm going to do quotient rule, but you really don't need to, because remember, you can write this as x to the third minus 4x. To what power? Well, to the negative fifth power. So now this problem looks a lot like the one we just did. So if we stay with what we talked about in the last example, we're looking for an inside and an outside function. So the inside function is always going to be this function being raised to a power. So that's x cubed minus 4x. The outside function is the power, right? Or the function being raised to the power. So as we get ready to do our chain rule, remember we're doing the derivative of the outside times the derivative of the inside. So for us, the derivative of the outside would be negative 5x to the one less power. So negative 5 minus 1 is negative 6. Right? But remember, what goes inside there is our original inside piece that never changes. Until we've written that, we're not really ready to do the derivative. Now we can come in here and say, okay, now I'm going to multiply by the derivative of the inside, and that is just 3x squared minus 4, and you're done. Okay, so that would be a good answer. Now, again, if you're looking for a different way to write that, you could say f prime equals, and then remember the negative powers can always be put on the bottom, so you could do that. And then on top, you can kind of just leave that. Okay, let's go through one where you have to combine the chain rule with either a product or a quotient rule. So let's suppose we start off with f of x equals x times x cubed minus 2 to the fourth. All right, so the one thing that we don't have available to us right now is the ability to distribute, and that's because of this fourth power up here. So we have to recognize the fact that we are really looking at a product of two things. So if you remember from our product rule, right, that's kind of like A and B. Right? So what a lot of people did was they said, well, if I make one of these, let's call one of them F and one of them G, right? If I call x function F and x cubed minus 2 to the fourth function G, then I can actually play around with some of their derivatives, right? So f prime, the derivative of x, just 1, and g prime, well, here we go. This is where my chain rule is going to come into play. So I'd have to do, right, the power rule. So I have to bring the 4 down. I have to rewrite everything I had in there, x cubed minus 2, reduce the power by 1, and then I have to multiply by the derivative of x cubed minus 2, which is just 3x squared. So how does that translate then to my answer? Well, let's think about this, right? When we do the product rule, right, it was like f g prime plus f prime times g. Well, I have all that stuff right here. Right? That's why I did all this work right here. So your final answer here would be the first function, so let's say x, times the derivative of g prime. And that would be all this long chain rule here you did. I'm even going to clean that up and say 12x squared times x cubed minus 2 to the third. So that would be the first part of the product rule, right? And then we're going to be saying, all right, well, plus, and then we have to do the other part of the product rule, right, which would be the f prime part. So that'd be 1 times the original g, which is just x cubed minus 2 to the fourth. And that would be your answer. So you can see now we're combining rules, and this is where it gets a little bit involved. There's really no need to do too much beyond that. We can even talk about it more in class. But so you're gonna, the idea here is you want to take these three problems, these three examples, you want to go meet with each other, the other experts in this group, talk about them, and then try the three problems in your notes together and see if you have any issues come up. And then your goal is going to be to go back to your Jigsaw groups and kind of share what you've learned. Remember, they haven't done this. They're doing something different. And you're all going to kind of teach each other these different pieces of the chain rule.